The next graphic is looking at an acid soil. So on our pH scale, this would be a soil represented by a pH of 6 or below. What has happened at this pH? At this pH, we have seen an increase in the hydrogen concentration on exchange sites at the expense of the base exchange sites, calcium, potassium, and or magnesium. In other words, we have a proportionately greater amount of exchange sites occupied by hydrogen in comparison to those occupied by the exchangeable bases, in this case calcium, potassium, and magnesium. This graphic would be very representative of a soil with a pH of about 6, maybe down to as low as 5.5. If we were to progress below the pH of 5 in the soil, a soil that is highly acidic, then what would happen is some of these additional exchangeable bases would be lost from the exchange site, and below a pH of 5 we would begin to see aluminum as an exchangeable cation enter into or onto this exchange complex. Now you'll recall from our previous discussion that aluminum, chemical symbol Al, has a charge of +3. So if you were going to put an aluminum on one of these exchange sites, it would have to take the place of 3 hydrogens, or if it were going to displace calcium, 3 calciums would have to be displaced to get 2 aluminums to go on there. It's going to be, in other words, on an equivalent charge basis. So the displacement of a monovalent cation like hydrogen by aluminum would actually occupy 3 of these exchange sites previously occupied by hydrogen. So soils that are slightly acidic will show an increasing proportion of hydrogens at the expense of basic soil cations, whereas soils that are highly acidic, getting down below 5, we'll actually begin to see aluminum becoming soluble and therefore entering into the exchange reaction and occurring on exchange sites.